There, Wildcats. Today we will start linear function. So to start with linear function, we need to discuss first your domain and range and relations and functions, right? So when we say relation, these are the set of ordered pair, meaning we have the value of x and we have the value of y. So your ordered pair is represented by, of course, the value of x and the value of y. And when we say relation, these are now set of values of x and values of y. And a relation is said to be a function when each input, okay? So there are new terms that we'll be learning as we go on. The input, which is usually the value of x. This is the input. Or element in the domain. Okay, so again, input or domain can be used there. Has exactly one output. Okay, exactly one output. So y is your output or element in the range. So we call this one also as range. Now you can only say that a relation, meaning it's a set of points. It can be represented in a table, it can be represented on a graph, it can be represented on set of numbers. The value of x, okay, or the input or the domain has a exactly one output or element in the range. Okay, so we'll be going and study deeper on this concept that we have on domain and range. Now, all the values can go into the relation or in the function as the input is called the domain. Again, the input is called the domain, and all of the values that come out of the relationship or function out, we call it output, are called the range. Range may also refer as as the image, as the product of all the input. So you just imagine a let us say you have a printer here, or let's just say you have a machine here, okay, and then you just place something here, which is your x, which is output, and then it will go and process it. And then of course we have that input, and then it goes out here. We call now that is your y, which is your range. Now by just looking at it, your domain, okay, these are all x values. These are all x values that are to be used, okay? And sometimes we call them as your independent. These are your independent values or variables. And then you have your range. These are all y values, okay? Y values that are used. So we call this one also as dependent values. So those are the the overall concept of your domain and range. And now we are going to use this concept on our first example. Our first example is that what are the domain and the range of the function? So how are we going to answer this one? As we go back on the discussion that we have just a while ago, the domain are the x values, and then the range are your y values. So you can now say these are the domain and these are your range. So we can write them as domain are set of Okay, maybe we can use this one. 1, 2, 3, 4, and 5. All right. Okay, sorry about that. So just put there. And then the range are the y values. So these are the set of 11, 12, 13, 13, and 13. Now that we're just looking at example number 1, and if you're going to analyze, the domain of the function is the set of x values, which are 1, 2, 3, 4, and 5. And the range is the set of y values, which are 11, 12, and 13. Okay, even though 3, 4, and 5 all map to 13. Okay, you see 3, 4, and 5, they map to 13. We still, okay, 3, 4, 5 is mapping to 13. We still consider that this given set of domain and range are still considered to be function, since each element in the domain maps to exactly one output. Okay, so 1 is partnered to 11, okay, 2 is partnered to 12, 3 is partnered to 13, 4 is partnered to 13, and 5 is also partnered to 13. And for us to easily identify functions, so we call this one as one-to-one function, one-to-one relation, one-to-one relation, meaning the value of x is partnered to just only one value of y, then this is a function. And then we have one-to-many. Sorry, this should be many-to-one. So your many-to-one, relation. So many-to-one relation, it's again still a function. Okay, so if it is one-to-many, the one that I wrote again, one-to-many, meaning one value of x is partnered to many. This is still be a relation, but not a function. So that is how easy you will identify if a given relation is a function or not. All right, so next is example number 2. Is the relation a function? If so, is it one-to-one or not one-to-one? Okay, first is identify the values of x and the values of y. And one of the best thing that you have to do also is you can draw a table and then partner the domain and the range. So in here, my domain, okay, my domain is, and in this one, guys, I'll just want to go back. You can just go and erase the extra 13 here. Okay, so sorry about that. There you go. So the domain here is the set of 1, 5, 7, and 8. And then the range here is we have 2, 6, negative 1, and 0. So there's no repeated number here. Therefore, this is a one-to-one. Okay, one-to-one, and again, it's a function. It's a one-to-one relation, and it's a function. All right, so that is our first example. Again, you need to look at the relation, if it is a function or not, by just looking at the value of x. Is it partnered with the different y's? So that is not a function if that's the case. Okay, so Next, on our third example, they ask us is the relation a function? If so, is it a one-to-one or not one-to-one? So we'll consider first if it is one-to-one or not one-to-one, and then let's consider let's answer if it is a function or not. So identify the input and the output, or the domain and the range. So these are the domain and these are the range. Okay, so by just looking at the domains are set of numbers 1, 2, 3, 4, and 5, and then your range, these are the dependent variable dependent values here. We have we have 17, 11, and 10. Okay, so because your x value or your domain, okay, is partnered to more than one element on your range there, okay, therefore this is not a one-to-one relation. Okay, since more than one element in the domain maps to a single element in the range, the function is not one-to-one. Okay, not one-to-one. However, okay, however, the relation is a function. Why? It is because every element on the domain, which is your 1, 2, 3, 4, 5, maps to exactly one element of the range, which is 17, 11, and 10. So your domain, just in case, it's just to make it simple, your the domain must only have one partner. Okay, the domain has only one partner. Okay, so that the relation will work. Okay, and your relation is considered to be function. Okay, that's one of the easiest explanation that we can give you here on the relations and function. Number 4, in number 4 problem, we have to the diagram shows the shipment or shipping charges as a function of the weight of several online orders. Based on the situation, what constraints, if any, are on the domain of the function? So first is, what do we mean by constraints? Okay, so what do we mean by this one? When we say constraint, these are the limit. Okay, is there any limitation on the values of the domain and the values of the range? So for us to understand that, by just looking at the table, okay, the domain, the input, or the independent variable, or the independent value, sorry, it's the weight of order in pounds, which is the orange here. Okay, next is the output, or the range, or the dependent variable, will be the shipping charges, meaning your shipping charges will only depend on the weight of the order. Okay, that's why we call it dependent variable. So basically, by just looking at that, an order, okay, of course, an order, the constraint here now is that an order must have a weight greater than, of course, 0. So the domain of the function is confined to the values greater than 0. So your domain must be greater than 0. So that the domain of the function is confined to values greater than 0. Right? So that's the limit there. Okay, there is no negative here. On this example only, on example number 4. So your order must have a weight greater than 0. All right, to summarize our discussion for today on this video, the concept summary is that a relation is any set of ordered pairs, and a relation is considered to be a function if and only if, okay, when each input or element in the domain has exactly one output or element on the range. So meaning your x is just only partnered once, okay, even if your x is partnered to several values of y, as long as your x, okay, so your x is partnered just once, okay, let us say 1 partnered to 2, okay, 2 is partnered to 3, and if your y value is partnered several times, that's what I'm saying a while ago, I'm sorry about the confusion there, the values of y, okay, if it is partnered to several values of x, it's okay, but your x must only partner to just one, exactly one, no more than one on the values of y. And you can the relations can be presented into a table, okay, can be presented to a number. This is how you write them. So each element in the domain associated with exactly one element in the range. So for numbers, the domain is the set of x values. Of course, those are the reds, okay? And then the blues are the range. It's the set of y values. So you have the knowledge on identifying the values of x and the values of y in an ordered pair. Second is you can present your, they can present and you can present also your domain in range using a diagram. So we call this one as mapping. Okay, each element in the domain is assigned one element in the range. Or we can also do graph. All right, so your graph also can be you can identify using graph. Now, after the concept that we have, we mentioned there graph. When we are graphing, okay, we have to make sure that we have to use the vertical line test in identifying if it is a function or not. So let us say a given value or a given graph, but there is no just they just give you the graph and then okay, identify if it is a function or not. So let us say I have here a graph. Of course, this is your x and y. So maybe I can just change the color there. All right, so I have several graph here. So let us say this is x and this is sorry about that. This is x and this is y. And then another graph has this. These are example of graph that we have here. This is x and this is y. Then another graph. This is x and that is y. So let us say I have here the green one. This is the first, and then the second example we have this. And then maybe we can just have a absolute value graph here. Okay, now we are going to use what we call now your vertical line test. So your vertical line test will test if it is a given graph is a function or not. Okay, of course we know it's a vertical line, so you just draw a vertical line on the graph. So example, if I'm going to draw a vertical line here, so draw a vertical line. I'll just use the red here. I'll draw a vertical line, draw a vertical line, and then draw a vertical line. So every single graph I draw a vertical line. Now, when will you say that it is a function or not? It is a function if your vertical line touches the graph once. So in number 1 and number 3, these are functions. Function. This is also a function. Why? Because it touches my vertical line once. Exactly 1 point. Now on number 2, number 2, not a function. Mr. Why is it not a function? Because when I draw a vertical line, it touches my graph twice. So that's one of the easiest way to identify if it is a function or not if given a graph. Mr. Why is that we use the vertical line? It is because as you can see here, these are the values of x. So the values of x only use once. But in here, let us say you're 3. Okay, let us say that is 3. That's the value of x. So 3 was used here, and 3 also used here. So you are now mapping. Let us say this is positive 2 on this y here, and this is negative 2. Take note that your 3, which is the x, was partnered twice to your y, which is 2 and negative 2, which is not supposed to be. Okay, to consider a given graph or a given relation as a function, your x must be partnered only once. Okay, so that is the overall reason why vertical line test is one of the one way to check if it is if the relation is a function or not. Okay, thank you so much, guys. If you have questions, just don't hesitate to contact me about this topic. Thank you, guys, and have a good day.